All right, look, this is Professor Parker. Welcome back to All This Math. Please make sure you subscribe to the All This Math YouTube channel. Make sure you like the video. Make sure you drop a comment down below. Make sure that you share this video with some people, some other people that need these skills. I think that's it. Let's get into it. So we're looking at a system of equations, a system of equations, a system because we have multiple equations. In this case, we have two equations, right? And each equation has two different variables, x and y, right? See, x and y, right? So we're about to figure out what values of x and y make this a true statement, and also the same x and y value that will make this a true statement. Because in math, it's all about finding out the truth. That's why when somebody say the math ain't mathing or something ain't adding up, it's because somebody lying, right? So math is all about finding the truth. That is what we want to do when we deal with math. We're looking for the truth. When we find the correct answer, that gives us true statements. Incorrect answers do not give us true statements. They give us falsehood or lies. All right. So, how do we approach this? There are three main methods of solving systems of equations. The graphing method, where we would graph each of these as linear graphs or straight lines and find out where they intersect. We're not about to do that right now. There's the elimination method, sometimes called the addition method, because you end up adding the top equation to the bottom, right? Or the substitution method. I'm not going to substitute because substituting will require a little more work than I want to do right now. But the elimination method requires less work. Now, here's a hint to know when you're supposed to eliminate, or, well, I don't want to say supposed to, but when you might want to eliminate, right? Or use the addition method. When your equations are both in standard form, what is standard form? AX plus BY equals C. That's standard form. Where you have an X term with a coefficient, even if it's a 1, it's still a coefficient, even if it's not written. Even though this is a minus sign, notice I said plus. Minus is the same thing as saying plus a negative. So this could be rewritten as 7x plus negative 4y. It's standard form. And then you got a constant on the other side of the equal sign by itself with no variable. That's standard form. So you got an X term, a Y term on the left side, you got a constant on the right side. That's all standard form is. Ain't nothing too fancy, ain't nothing too crazy. Don't let that intimidate you. Second equation, that's standard form too. Because look, I got an X term, I got a Y term on the left-hand side, and I got a constant on the right-hand side. All right? We both in standard form. And look, vertically, the X's are lined up on top of each other, the Y's are lined up on top of each other. Now, again, when we do math, everything in math has a name, and it has a name for a reason, right? Because the name is associated with the process that we're going to undergo or what's going to actually take place, right? So we're going to eliminate one of these variables by adding the top equation to the bottom equation, top equation to the bottom equation, top equation to the bottom equation. That's why some textbooks or curriculum call this the addition method. So if you see addition method, think elimination method. You see elimination method, think addition method. All right. Now, what I would do is I would eliminate the y's. Why would I eliminate the y's? Because if I change this to a positive 4y, then that means when I add these two equations together, I would have negative 4y plus 4y. And negative 4y plus 4y adds up to 0y, which is the same thing as 0, which means that the y's would be eliminated. Let me say that again. If this was a positive 4y, instead of being a positive 2y, if this was a 4y, then when I add the two equations together, I'm going to have negative 4y plus 4y, which adds up to 0, because negative 4 plus 4 adds up to 0. If a negative 4 means I owe somebody $4. If I owe somebody $4 and then I give them $4, that's plus 4. Now I don't owe them nothing. We even. We even now. It's square business. We even now, right? So negative 4 plus 4 adds up to 0. So I'm going to eliminate the y's. But here's the question. How do I change this 2y into a positive 4y? How do I do that? I use multiplication. I'm going to multiply this by 2. If I multiply this by 2, it's going to become a 4. But dig this, though. I can't just multiply that by 2. I got to multiply the whole equation by 2. The whole second equation by 2, or the whole bottom equation by 2. So this is what that looks like. You draw parentheses around the whole equation, and then you put a 2 outside. And I could have wrote it in the front or the back. It don't matter. It's up to you. It's your prerogative. I just chose to write it right here because it looked like it was a little more space. Now, I multiply this whole equation by 2. I'm not multiplying this equation by anything. It's going to stay the same because remember, what is my goal? I want to eliminate these y's, eliminate these y's, eliminate these y's. That's what I want to do. So now I'm going to draw a horizontal bar, And I'm going to rewrite the top equation. I'm not changing nothing in the top equation. I got 7x minus 4y equals negative 7. I got 4x plus 4y equals 40. Do not forget, when you multiply, when you find that magic number that you need in order to get the term, get the coefficient the way you want it, don't forget to multiply everything by that number. All right? Everything gets that too, right? Everything gets that too. This 2 is for everybody. This 2 is for the streets, right? So everything gets that too. So now, watch this, right? We're going to do this. Now we're adding, right? We're not subtracting, we're adding, right? Even if we end up subtracting, because we're adding a negative, right? So we do 7x plus 4x. That equals 11x. Negative 4y plus 4y. Boom. It adds up to 0. It's eliminated. That's why this is called the elimination method. The elimination method. We just eliminated the y terms. We eliminated them. We could have eliminated the x's. We would have had to do a little more work. We would have had to multiply the top equation by a certain number and the bottom equation by another number. We could have did that, but I chose not to do that in this particular problem. All right. So we eliminated the y's. Now over here, negative 7 plus 40 is positive 33. Make sure you know how to add and subtract positive and negative numbers. That is mandatory at this level. All right. So now we got 11x equals positive 33. How do I get rid of this 11 so I can solve for x? I got to do the opposite of multiplying by 11. So when you multiply by 11, the opposite of that is dividing by 11. So we got to do that. We got to divide. Whenever you want to get rid of something, you got to do the opposite operation. So I divide by 11. We got to keep things balanced. That's another principle within algebra, balance, right? Just like in ancient Kemet, Mayat, right? Balance. So if I divide by 11 on the left side, I need to divide by 11 on the right side. So I got 11 divided by 11. They become ones. 1x is equal to just x. 1x is just x. And 33 divided by 11 is 3. Make sure you know your division facts and also your multiplication facts. If you know that 11 times 3 is 33, then you should know that 33 divided by 11 is 3. Now, we are not done. Don't stop there. This is a system with 2 variables in it. You need to solve for both variables. I know what x is, or at least I think I know what x is. Now let's go back and figure out what y is. How do I do that? Pick one of the 2 equations. Does it matter which one? No, it don't matter. It don't matter which equation you choose. Let's choose the top one. So I'm doing 7 times, not x, because I know what x is. I don't need the x no more. I know what it is. It's 3. So instead of saying 7 times x, I'm substituting 7 times 3. Even though this is not the substitution method, I still end up substituting to find the second value, the value of the second variable. Minus 4y equals negative 7. Now let's do 7 times 3. That's going to be 21. Minus 4y equals negative 7. Now let's isolate negative 4y. So we're going to do minus 21 on the left, minus 21 on the right. Boom, boom. That cancels out. Negative 4y equals negative 28. Now I'm trying to get y by itself. I got to get rid of that negative 4. How do I do it? Opposite operation. The opposite of negative 4 times y. Division. So we're going to divide by negative 4 on the left. Divide by negative 4 on the right. Boom, boom. Y equals positive 7. A negative divided by a negative is always a positive. Negative divided by negative is always a positive. So we plugged in 3 in the top equation to figure out that y was 7. So when we go to check our work, which you must do, because these numbers must work for both equations, not just one, both equations, right? We still got to plug in to the second equation. What I'm saying is we don't need to check it in the first equation because we just used the first equation to figure out that y was 7. And we can do it, right? 7 times 3 is 21. Minus 4 times 7 is minus 28. So 21 minus 28 is negative 7. That's true. Now let's go to the second equation. What's 2 times 3? Because x is 3. So 2 times 3 would be 6. What's 2 times y? 2 times 7. 2 times 7 is 14. What's 6 plus 14? It is 20. 6 plus 14 is 20. That means that's a true statement. So if you have a true statement, that means we found the truth. That's the purpose of math, is to find the truth. All right? That's why people don't want us to learn math, because then we might start finding out what the truth is about much more complex scenarios and questions and problems in everyday life and in society and all that. I'm trying to tell you, learn the math. Don't run from the math, run to the math, right? So this is our solution. We could just leave it like this, x equals 3 and y equals 7, or we could rewrite it like as if it were a pair of coordinates on the coordinate plane, and we could say 3, 7. We could do that. You know what I'm saying? So it's different ways to write it. But look, this is the elimination method. All right, not the substitution method, not the graphing method, but this is the elimination method. Why is it called elimination method? Because you pick a variable that you want to eliminate. Which variable should you eliminate? It don't matter. It's up to you. You got power. When you know how to do algebra, that's empowering. You got power. I had the power to say, you know what? I feel like eliminating the y's. I could have just as easily said, you know what? I feel like eliminating the x's. You know what? I might do another video where I eliminate the x's instead of the y's. I think I'm gonna do that. Not right now because I gotta roll out and go pick a side up from dance practice, but um at another time, right? Because I could have decided I wanted to eliminate the x's, and I could have figured out how I could have reconfigured these x terms so that they would have been opposites, right? What I would have had to do is I would have multiplied this by 2 and this by -7. This would have become positive 14x. This would have become negative 14x. Positive 14x and negative 14x. And that's just one option, right? That's not my only option, right? But that's probably what I would have did though, right? Because sometimes with these elimination problems, sometimes you only need to multiply one equation by a factor, right? Sometimes you need to multiply both equations by different factors, right? But if I wanted to eliminate the x's, I would have had to multiply both equations in order to make these exact opposites. Because when you want to eliminate, you got to make those coefficients exact opposites. Write that down in your notes somewhere. When you want to use the elimination method, you first pick the variable that you want to eliminate, and then you got to figure out a way to make the coefficients of those variables the exact opposites, meaning positive 4, -4, positive 10, -10, positive 20, -20, positive 5, -5. How you going to do that? You got to figure out how to do that. So at that point, it's like a game. It's like a little puzzle. That's why I like the elimination method. It's cool. Sometimes I like the substitution method better, but it just depends on what type of mood I'm in for real, you know. But yeah, this is the elimination method. Like I said, make sure you subscribe to the channel, drop a comment down below, share the video, tell some people about what we're doing at All This Math, and I will see y'all on the next video. I'm out.